well, what you're here for this trip for is you're talking about how the JavaScript VM works. Can you talk a little bit about?
So I, as I said, I originally designed CPUs, like not CPUs, but like hardware, right? Like chips.
Mm-hmm.
I did design a very simple microcontroller as part of my thesis when I was in undergrad. And so I was always interested, like, how does this work internally? And if you think about it, what a JavaScript, it's called a virtual machine, right? And the word virtual really means that, like, hey, this isn't real. This is not how computers actually work, right? We're creating a pseudo world for you, so you have an easy environment for coding, but that's not actually what happens underneath. And the job of JavaScript or any kind of a virtual machine is to translate those particular things from this high-level concept of what JavaScript is to the low-level concept that the CPU can execute and perform. And it turns out that if you know how CPU works, many of these bottlenecks of like how JavaScript is slow in particular areas become really obvious. Like, of course it's slow in this particular way because this is actually how CPUs work, and the delta between what you want out of JavaScript and what the CPU is actually done underneath is pretty big, and therefore, it becomes slower because the emulation is more complicated. And so the talk or the workshop we're going to be doing tomorrow, right, is really about that, about like how exactly do CPUs work and how do virtual machines solve many of these common problems like function calls or property access on object, and how the solutions kind of dictate the performance under which things perform well and then sometimes when things don't perform so well.
Hello, everybody. I'm Mark Kubanski, CEO of Frontend Masters, and today is exciting because we have Miško Hevery on the podcast. He is the creator and father of AngularJS. He created Angular and then now Qwik, and he has had an amazing career going from hardware and microcontrollers all the way to 15 years at Google, advocating for testability. He cares about testing and performance, and we get into all of that going through his career, and it's just a really fun conversation. So hope you enjoy the podcast. Alrighty. Well, welcome to the podcast, Miško.
Thank you. It's good to be in Minnesota again for the third time for me.
Yeah, third time. Well, this time it's actually good weather. The first time, I remember it was like probably 20 below zero when you came.
The first time I came here was crazy cold. The second time we got diverted to Fargo. I didn't even come here. Didn't make it here. So finally, an uneventful flight, which just landed the way it's supposed to be.
And it's beautifully.
It is beautiful today.
It's like 80 degrees, and when I run, it was gorgeous. So we're gonna start out with some warm-up questions. We're gonna get into a little bit of early career. We're gonna go talk about AngularJS those days, and then of course we'll get into your favorite subject, which is Qwik today. So, are there any special skills that you have that people might not know about?
I'm not sure if they don't know about it. I think they do know and they dread it. And I like dad jokes, and I like make people squirm with, the worse the better, in my opinion.
All right. So can you give us a dad joke?
Yeah. So, I especially collect ones for software engineering. So, how do functions break up?
How do they break up?
They stop calling each other.
Oh. It's a good one.
Come on, it's better than you're acting.
It's amazing. I'm blown away.
But do you know how long did the program run for?
How long?
For a while. No? All right, let's go.
All right. So let's talk sausages. What makes a good sausage?
Lots of fat.
Okay.
I have a crazy hobby. I make sausages sometimes. I think it's fun. You start with, some meat, you add some bacon to it, grind it all up, fill the casings, and then smoke it at home. And then, it makes a good sausage. I also joke with my kids that it's social capital. It's social currency. You give out sausages and you say you made them, and then people enjoy it.
Absolutely. So how much do you make at a time?
Not that much, because my smoker's not that big, and usually I can only do about like two rounds of it. I want to say something like around 20 pounds worth of meat. But, when you smoke it, it dries down, it becomes lighter, etc. So you end up with a lot less.
I see. Yeah, I was going to say 20 pounds is a lot of food.
Yeah, well, you don't eat it in one sitting,
Yeah. All right. Well, it seems like a challenge. How about woodworking? You've been into woodworking as well.
Yeah, I like building things, like whether it's software or hardware or woodworking or anything of that sort, 3D printing, 3D modeling. Yes, I did some furnitures and around the house and things of that sort. So I do that when I have
Like, what's your
something.
favorite piece you made?
I made this cool looking table that kind of comes like this, and you interlock it, and then the two legs are just kind of standing. My wife said, like, we need to place something over here. And I was like, yeah, we'll make some cool table or something. So we put one together.
So can you like take it apart and put it back
You can.
together? Like,
I didn't tell that to anybody so that nobody pulls on it, but maybe I should, because if you grab it in the middle and try to pull it by the middle, it will come into pieces.
that's very cool. So then you also do 3D printing as well.
Yeah, I do a lot of 3D printing around the house. A lot of things is 3D printed. Random things, basically. When you have a 3D printer, you kind of look at the world in a slightly different way, where you're like, ooh, I wish I could solve it if I had X. And then the answer is like, well, you can have X, right? You can design whatever you want. I think yesterday I was looking at my kid's desk, and he had a computer and a keyboard and was like taking up the whole space, and there was no place to do homework. I was like, it would be so nice if your computer was a little higher off the desk. So we printed some legs and put it underneath, and now the keyboard can slide under the computer. So things of that sort.
Cool. Give us one more project.
The big project I did is I wanted to have a disposer in like this island sink, and there was also a space for like a mini fridge to make cold water, and the two wouldn't fit because the disposer has to go in the middle because the sink is in the middle and the fridge is kind of on the side, and so I had to put the disposer to the side, and now you had to build this like complicated drain pipe to kind of offset the disposer, and so that was kind of a complicated project. It took me about a week of CADing and experimentation and
Well, that's something you're never going to be able to buy in the store.
No, you can't buy that, right? Like, you just cannot buy. That's not a thing that you can
That's
buy.
very, very cool. Or you can just
It is.
solve problems around them.
Yeah, you solve problems
environment.
that you have that only you have. It's a one-off kind of problem, right?
And last warm-up question, can you tell me about your door frames?
I don't have door frames. So when we were building a house, we wanted to make sure that it kind of was minimalistic and clean looking as possible. And when you're building a house, really kickboards and door frames is where you hide all the ugliness of your craftsmanship. And so having a frameless doors is actually kind of tricky and hard. And so
I've never seen them.
Yeah, they're not very popular in the U.S. They're a lot more popular in Europe because Europe's more kind of a modern style, etc. And so it's a special kind of a frame that they manufacture for you, etc. And they have it kind of as a set in Europe. So it's quite common in Europe. It's not an extraordinary thing.
So you must have had to custom build your home in order to get that.
No, you just, it's just a normal door frame. It's a special frame in the sense that it's an aluminum extrusion that goes around the door. And this aluminum extrusion is such that you can screw a sheetrock into it. And then the gap between the sheetrock and the aluminum extrusion gets filled with putty. And so it ends up looking without any frame.
Yeah, I bet it looks like super cool.
It looks nice, yeah.
All right. So yeah, let's get into early career. What's your earliest memory of writing code?
I remember, I think it was like early 80s. My dad got a computer, and I remember early 80s, we are in Slovakia, which is a communist country or socialist country or whatever the phrase is back in the day. And, computers are, people don't even know what they are, right? And so the fact that I had we had a computer was kind of unusual. And so I taught myself BASIC together with my dad. We kind of started coding, etc. And I remember at some point, computers became a little more popular, maybe a couple of years later. And there was a competition in like a regional city. And I enrolled in a competition, and I got disqualified because nobody believed that I did the software. And now, looking back today, I'm like, this was a kind of a really simple game that took me, I don't know, maybe a couple hundred lines of code, like nothing really complex.
And this was like the late 80s? Then?
This was like mid-80s.
Mid-80s, oh yeah.
But, to get disqualified is like, it's the ultimate reward, right?
Yeah. It's like, I used to play competitive video games, and the ultimate compliment is hacker, right?
Yes.
Hacker. Yeah, and you're like just dominating the room. So anyways, yes. If somebody accuses you of cheating and you have not cheated, that is the best compliment, absolutely. Looking at your whole pedigree, I mean, you've had quite the career, even like you did 15 years at Google, but even before that, there's like Sun Microsystems, Adobe, and then I heard you did an internship at Intel. Could you?
Yeah, so I actually started, my degree is in computer engineering. So crazy enough,
Okay.
I used to design chips, right? So like all the way down to layout of silicon and transistors, etc. That's what I studied. And somehow slowly I moved toward the software. Like I knew I wanted to do something with computers, when I was already in high school, like mid 80s, I was a kid, right? So
Yeah.
I was high school in early 90s. And I knew I wanted to do something with computers. I didn't even actually know what the proper term was. It wasn't even clear to me what the difference between computer science and computer engineering was. Anyways, I ended up doing computer engineering, which is a mixture of basically software and hardware. And then as I graduated, as I said, I had an internship at Intel. We actually worked on a 440LX chipset, which is, back in the day when things were separated, they weren't all system on a chip kind of a thing. So I did Intel internships, and then as I graduated, I slowly went into embedded systems, like doing software for printers, like the software that's actually running in your physical printer that controls the device, right?
So like printers are demons. Did you like put the demons in there?
No, I mean, but like
No, I'm just kidding.
a printer receives a Postgres file, right, and it has to parse it and
But
decide.
like printers are always broken. Anyway, sorry. Go ahead.
Yeah. So I did some of that software.
I see.
And then, when I went to Adobe, we started kind of moving more and more further away from kind of the hardware, and I did more and more software.
Okay.
I went into the backend systems. The company I was working for decided that internet was a thing now, and so they trained all their employees on databases, and so that's how I got into databases. And so there was like a slow progression from like literally transistor to higher and higher levels until I kind of ended up in software, and then I ended up in front end. And if you think about it, front end is pretty much as far away from the hardware as you can
Yeah,
get.
absolutely.
And so I like to joke that I'm like one of the few JavaScript engineers who knows how the transistor works.
Yeah. That's probably a true statement.
And, most things in between, because I've kind of done it at some point, whether it's embedded systems or backend systems. But yeah, for the past good 20 years, it's been mostly front end, mostly at Google. And
Yeah, I mean, you went to Google at
frameworks.
like 2005, which is like early days of Google. Like,
Yeah.
How did you end up there?
Actually, I had an interview with Google before 2005, and I didn't get the job the first time through. It was a kind of an interesting interview because they asked me something about inheritance. And so I answered it, and then the person interviewing me said, well, no, I'm wrong. And I was like, I'm pretty sure I'm right. And so like, is this a test? Like how I behave when like the interviewer, tells you that you're wrong? So I was really puzzled by this thing, like I'm pretty sure I answered the question correctly. You're telling me I'm wrong. Like, so what exactly am I supposed to do? I went home and I brought up a little example program and sent it to them saying like, look, I'm right. Anyways, I think they thought I was cocky or something because I did not get the job the first time through. Then I had another interview maybe like 4 or 5 years later. And then that's...
So you interviewed at early.
Yeah,
Google.
super early where they had like 1,000 employees.
Okay.
Should have gotten in then, right?
Yeah.
I guess I missed the boat. I don't know. That question really got me.
Yeah, it all came down to inheritance. You would have been rich and would have had inheritance.
You know why C++ programmers are richer than JavaScript programmers?
Why is that?
Because they have multiple inheritance.
Writing programs with multiple inheritance is...
No, it's a bad practice.
Not great.
No.
Not great. Like one layer, I've seen one layer work out pretty well of inheritance, but not anything more than that. Yeah, I mean, truly, honestly, I interviewed at Google around that time too. It was like 2005, 2006, and they rejected me because of my college. I didn't go to like one of the Ivy League school colleges.
I did not either.
So, but yeah, you had this illustrious career beforehand, so I'm sure that got you in.
I think by the second time through, I think they were a little less stringent about these things. But that was a long time ago.
For sure. How about your time at Google? I mean, when I met you, you had been like, I think you said you were a testing evangelist or something like that, or testing.
Yeah.
But like, I'm sure you had roles prior to that. And how did you find yourself there?
So I was hired just as a software engineer. And this was at the time where people in the industry were kind of debating whether testing was a good idea, whether it's actually helpful or was just like extra bunch of work or something like that. And while I was there, I was actually working with a consultant company and made friends with this guy, and he showed me how testing was done through test-driven development, and I really enjoyed it. And I thought, well, this is really cool. I want to share thoughts with it. So I started doing a lot of talks within Google, kind of sharing the knowledge and explaining things, etc. And they kind of got popular. And at some point, Google...
So those Google Tech Talks?
Or the Google Tech Talks. And there's many of them are still on YouTube, I think.
Okay.
And at some point, Google decided that testing is a thing and we should convince people that they should do more testing. And so they had like a internal task force to go around and basically teach a man a fish. Don't write the test for them, but show them how testing is done and bring them for it. And so for a while, it was called Test Mercenaries. For a while, we would go around in different teams and kind of teach them like, hey, you have this big code base that's not many tests. How do I add tests to the code base, et cetera? And so for a while, I was kind of an evangelist of this. And then at some point, I kind of was like, okay, I'm kind of done with testing. I want to build something. And this is where AngularJS came to be, because I wanted to kind of say like, hey, could I have a non-developers make an application, right? Like, what would you do? Like, how do I lower the barrier of entry to making an application? And HTML was kind of a big thing back then, right? The internet was just happening. And so the question really was like, could I just add extra vocabulary to the HTML to make it easy to build web apps? That was the original idea behind AngularJS.
Yeah, and I actually ran a conference at Google headquarters when we met. Like, I can't remember who introduced us, but I ran this 250-person conference at Google headquarters. They offered me a job then. Like, hey, 'cause that conference went really well. But then after, I think it was the day after, you and I and some other folks, we like had lunch, and you were telling me about this framework, AngularJS, and I think it was like 0.5 beta or something at the time, and
very, very early version.
Yeah, I think it was like even like a pink or a purple website or something like that.
Yeah, it was a very different website. I'm not sure they already had the name Angular. I can't remember.
Okay, yeah, it might have been called something else.
I think it was Angular by that point.
Okay, yeah. Anyways, but yeah, you were telling me about this, and it made a lot of sense. Like, especially at the time where, I mean, you pretty much only had Backbone. Right. And
yeah, Backbone was the only thing in town. And the thing with Backbone was that if you think about it, Backbone was really just the reactivity portion, and then you had to bring your own UI and data binding and all the other pieces. So there's a lot of glue code that you had to write with Backbone. And Backbone was really made by engineers for engineers. And I think the big difference with Angular was that Angular was originally meant for non-engineers, right? The idea was like, how can non-engineers do development and build websites, and so it was really focusing on like the experience, right? Like not necessarily developer experience, but like the building of the app. Wanted to be as simple as possible. Turns out that what's simple for other people is also simple for engineers, and so engineers really love that.
Yeah, and then you had the kind of testing background and everything.
Yes, and Angular, I think, also was one of the first frameworks where the testing was kind of built in. It wasn't kind of an afterthought. Like the whole framework was designed about the idea of like testing and how do you make sure it's testable and so on.
Yeah, I think we're actually writing. Well, okay, so I invited you to give a workshop, and that was like the early Front-End Masters. So it was like over a decade ago, and you came to Minneapolis and taught AngularJS, I think 0.6 beta, I think at the time. It was not long after we had met, but you came and gave that workshop. And but on the car ride over, you were like, how did Backbone JS become so popular? And I think my answer at the time was demonstration, like demo code. Like if people can see it working right away and it just makes sense, that demo page, then people are likely to adopt. I think that was my answer at the time. Like, what would you say that you obviously made AngularJS popular, but what do you think contributed to that?
Well, it was definitely a part of that was making it easy. But I think the second part is like you have to solve a problem that people have, right? And so Backbone was solving a problem in the sense that people were moving into building complicated applications, and nobody really knew how to structure them in a way that's scalable and maintainable, etc. And so, Backbone was a part of the story. I think what made AngularJS different is that just like Backbone, it solved the problem, but it solved it in a much kind of a simpler way, right? And so the barrier to entry was so much lower. I remember a lot of people, the original website on AngularJS, right, was like, hey, insert the script tag into your head, and then put these extra tags inside of your HTML, and all of a sudden you have a to-do application, right? And I think that blew a lot of people's minds that like, hey, you could have filtering and sorting and all kinds of things, and you don't even really have to write any code. And I think that's really what kind of took off for Angular is Angular was the first time when all of these things were put together, the reactivity, the data binding, the testing story, like everything was there served up in one nice package.
Yeah, and that kind of obviously moved on to like Angular, right? You dropped the JS part and made it into Angular and like adopted TypeScript really, really early on and kind of like paved the way in that. Could you talk to us about kind of that transition? I know there was...
Yeah, so AngularJS became popular. Interestingly enough, it became popular outside of Google first and then was brought into Google. And there were teams using AngularJS at Google, and the problem was that Google teams are large, like hundreds, maybe sometimes even more people on a project. And if you have no type system, you get into troubles, right? Like you don't know what thing is load bearing, what you can change, etc. And so the code essentially becomes read only, right? Write only. You can write the code, and everybody's afraid to modify it because what am I breaking by modifying this particular thing? And so one of the things we wanted to achieve with Angular, or originally we called it Angular 2, was making sure that large teams can adopt it, right? And so part of the story is type safety, right? Because the thing that type safety gives you, for one, it forces you to give things names, right? And by giving things names, it's just so much easier to talk to your coworkers. That alone is a useful thing, right? But it also enforces that consistent and you don't make mistakes, etc. It catches the obvious kind of faults. And so we needed something like that. And there was idea of whether we build something ourselves. And so for a while, we had this idea of building this thing called AdScript. But lucky enough, Microsoft reached out to us and they said, hey, we're working on this thing called TypeScript. What do you think? Would this solve your problem? And then we have to look and we said, yeah, that definitely would solve our problem. We should definitely go this particular direction. And so we became early proponent for TypeScript. I think TypeScript would certainly be successful even without Angular, but I think Angular did help TypeScript get there faster a little bit.
Yeah, that's interesting. So Angular, the whole like kind of the bigness of Angular 2, like the scope of it and everything with TypeScript and having like all of like everything that you would need to build an app, that came from pressure from Google?
That was internal stuff, yes. Like we saw people building large applications and then running into trouble. And so the idea behind Angular 2 was like, can we fix those things, right? So unfortunately with Angular 2, it was no longer like drop a script tag and
right. It was much more complicated.
It was a lot more complicated, but a lot of these complexities was there specifically to address the need for large-scale systems.
And that makes sense because I think we're seeing a lot of adoption in the enterprise space because like when it comes to some of these other frameworks that don't have that kind of like large scope of testing strategies and yada yada yada, they end up piecing together a completely different looking app or set of tools for every single application, which obviously when you're building lots of applications with large teams, that's a bit challenging.
Yes.
So, yeah, that's cool. So, yeah, I also, what you're here for this trip for is you're talking about how the JavaScript VM works. Can you talk a little bit about?
So I, as I said, I originally designed CPUs, like not CPUs, but like hardware, right, like chips. I did design a very simple microcontroller as part of my thesis when I was in undergrad. And so I was always interested, like, how does this work internally? And if you think about it, what a JavaScript, it's called a virtual machine, right? And the word virtual really means that, like, hey, this isn't real. This is not how computers actually work, right? We're creating a pseudo world for you, so you have an easy environment for coding, but that's not actually what happens underneath. And the job of JavaScript or any kind of a virtual machine is to translate those particular things from this high-level concept of what JavaScript is to the low-level concept that the CPU can execute and perform. And it turns out that if you know how CPU works, many of these bottlenecks of like how JavaScript is slow in particular areas become really obvious. Like, of course it's slow in this particular way because this is actually how CPUs work, and the delta between what you want out of JavaScript and what the CPU is actually done underneath is pretty big, and therefore, it becomes slower because the emulation is more complicated. And so the talk or the workshop we're going to be doing tomorrow, right, is really about that, about like how exactly do CPUs work and how do virtual machines solve many of these common problems like function calls or property access on object, and how the solutions kind of dictate the performance under which things perform well and then sometimes when things don't perform so well.
Yeah, and obviously V8 is the big runtime that everybody uses, but then there's also like WebKit
and Spider-Man Key. It turns out while they're different implementations, they kind of use the same strategies. There's only so many strategies people have for dealing with the differences between what an object is and what's laid out in memory. And so even though the details are different, they kind of work the same way.
Huh. That's cool. Well, I'm really looking forward to it for sure.
Thanks.
And so, yeah, I guess the two areas that we've kind of talked about are performance, which is like understanding the VM, and then testing. What does make code testable?
That's a good question. It's easier to say what makes code hard to test.
Yeah.
So preventing you from getting hold of the inner parts is kind of what makes it hard to test. Calling functions they reach out to the outside world makes it hard to test.
Side effects,
etc. Right? And so a lot of the testability is just making sure that you can get a hold of all the parts that are moving, all the moving parts inside of the algorithm, so that you can then say like, okay, what happens if I control this particular part? How do the other parts behave, right? And so a lot of testing really just comes down to, can I design my system in such a way where parts of it are swappable out with other things? And it turns out when things are swappable, you can put in mocks or tests or logs or kind of make sure to ensure that things work right. But it turns out that if things are swappable, it's also better designed because, well, if things are interchangeable, then it's probably more well thought out than when it's kludge that only works one particular way and no other way.
Yeah, so I think about like the concept of pure functions and functional programming.
Yeah.
Well, is that kind of what you're talking about? Or is it a little
so a
bit
pure
different?
function, right, doesn't have any hidden state. And so by definition, all of its state comes from the outside world. And therefore, you fully control the outside world, right? And you can make it easier to assert that they actually did the right stuff.
And then with performance, what are like the most common gotchas as far as like killing your performance?
So I think there's micro optimization and macro optimizations, right? It's hard to talk about like gotchas and macro optimization level that's specific to your application. But in micro optimizations, especially in JavaScript, it's important to understand how inline caching works and under what circumstances the VM will have to de-optimize the code. And if you understand this, you probably understand about 80% of like the tricks you can do to make sure that you make the life of the VM easier. And of course, easier means they can execute faster.
How about like in web development today? Like, what do you think the types of applications that you're seeing that people build? Like, what are the generally common gotchas that you feel like?
I think we're kind of living in this transition world where we have had frameworks, like Angular and React, that their attitude has been just recompute everything, right? If you change anything, just rerun the whole process and recompute everything. And Angular does it through dirty checking, and React does it through a VDOM. But if you think about it, VDOM is just a dirty checking in a slightly different way. And so I think what's happening now is that we have a new set of frameworks that are coming out, like Svelte, Solid, and of course Qwik, which is really heavily leaning on signals. And the whole trick of signals is do less work, right? And so the big gotcha, I think, is that we have kind of gotten happy with the fact that like it's okay, computers are fast enough. It's okay to just re-execute the whole application again or rerun all the components, etc. And it's okay until the app is big, and then it's not okay. And the problem is that once it's not okay, there isn't a really easy way to kind of get out of it, right? And so we kind of back yourself in a corner. And so people spend a lot of time and effort optimizing things. They get it to a good performance only to add a couple more features and the performance degrades again, right? And it's this countless back and forth. And I think part of it is that the current set of frameworks that we have that don't use signals have this attitude of like, let's just recompute everything all over again. It's predictable. That's a good quality. It's simple to understand. That's a good quality, right? It's straightforward, but there's a consequence.
Yeah, and some of the apps that I use, I feel like they just like take up so much memory, and it's like, why is Chrome eating up all the memory on my machine? And I think, in a lot of ways, that's kind of what you're talking about with like.
But also, I think there's been like this attitude of like, it's fine, it's good enough, it's fast enough, like don't worry about it, right? But I wonder if it's part of the sour grapes story where like, oh, nobody knows how to make it fast, and so people convince themselves that like, oh, it's good enough what we have.
I would definitely agree that that's part of it.
Yes.
That's part of it. So then you've created, Qwik to kind of address some of these issues, right?
Yeah. So Qwik is very unique. Like, I think one of the biggest problems we have right now is the startup performance, right? If I go and navigate to a site, it takes forever for me before the site becomes interactive. And I'm sure you've seen sites where you're like, you just want to have a simple answer or something. You navigate to a site, and then you're like ready to click, and it doesn't work. And then finally it starts working, but the pop-up comes up and it shows you something else. And like then the layout shifts, and then you're like, can I just get to my information that I need, right? And it takes forever. And it's because of how we build apps. And basically the way we build apps, as I said earlier, is that we just re-execute the whole world, right? And this re-execution of the whole world is fine for desktop apps. It's fine for games. It's fine for many scenarios. But if you're in a web where you have to download everything, to execute the whole world means you have to download everything. And to execute the whole world means that the JavaScript VM has to run and parse and do everything. And remember, before all these benchmarks that we have that show how amazingly fast our frameworks are, those benchmarks are once the VM has warmed up and has executed your code many, many times over. On an initial render, none of that stuff applies. You're running in the super slow interpretive mode where, you could be easily 50 times slower than what you would do once you warm up the VM.
Well, I think about when people are like, oh, if I include this library or this framework, whatever, it's just like one extra image or something.
Yeah, it's
right?
a death by 1,000 cuts.
But it's not one extra image. Like the browser has to not only download that, but it also has to parse and execute it.
So the argument is that like it's an extra library is like an extra image. I think what that argument is missing is that it's not about the bytes on a wire, although that matters too. It is the fact that has to get executed and parsed and ran, right? And it all adds up. If this extra, library that you're including adds 100 milliseconds, you're like, well, that's not a big deal, 100 milliseconds. Yeah, but like how many do you include? 50, 20, 100 different libraries, and each one is 100 milliseconds here, 100 milliseconds there. Next thing you know, it's 5 seconds on a desktop, and you run on a slower mobile device, and all of a sudden it's 30 seconds on a mobile device. Add to it a network that is not maybe the best, and you end up with like really difficult to use websites. So the big thing that Qwik tries to solve is basically kind of flip the whole thing on its head and say, how about we live in a world where we don't need to execute the whole thing? How about we have a framework that from day one says it is my responsibility to figure out how to lazy load everything, how to chunk up everything into pieces, and how to just not execute everything on startup, rather than the current set of frameworks basically say like, oh look, you can do these amazing things. Oh, it's slow? Well, that's up to you. Here's like different tricks you can do to optimize. But all these different tricks have limitations, and we can get into them. And so I think fundamentally, I think the problem of lazy loading and not executing everything at the beginning is a framework's responsibility, right? If the other frameworks use hydration as a form of getting the application ready, and hydration requires that you execute every single component that's currently rendered at least once, that's a problem. right? Because you have to download it all, you have to execute it all, and it takes time.
Yeah, I've looked at Qwik. Obviously you gave a workshop at Frontend Masters on it, and it's really, really cool. Like the fact that with other frameworks, yeah, it's like you get to this world of like, okay, there's way too much payload on this. Okay, now I can chunk it, and there's like a Webpack way of doing it and a Vite way of doing it, but like everything is, the act of having to do those things and break apart your app requires maintenance. It requires keeping tabs on it and all that kind of stuff. Whereas you're saying, okay, well, we chunk up everything automatically, and like each click or whatever is an entry point into the app, and I'm only loading exactly.
Yeah, when I demo Qwik, a lot of times people say like, well, I can do that in my favorite framework. And they're not wrong. Like, yes, you can do all of these tricks. Mm-hmm. The thing is, all of these tricks require a huge amount of time and effort. Like you could do lazy loading, but then you have to like move your code into a separate file, leave dynamic imports, put lazy wrappers, suspend boundaries. That's a lot of work that most people don't do. And then even if you do that, then like, well, how do you know when to prefetch the code? And how do you have to make sure that like what happens when the device the application goes into a tunnel and there's no network? And so all of these problems are things that, yes, you could solve. There are tools that you could do, but vast majority of people don't because there's just no time. And so my point with Qwik is that with Qwik, it's not your responsibility. Like Qwik just solves it for you out of the box without any effort. Even if you build Hello World, right? You get all the machinery for lazy loading, for downloading as little as possible, for SSRing your page, for prefetching the right stuff. So even if you go to the tunnel, the interactivity is still there.
Yeah, I think it's pretty cool that like the lazy loading happens like in a service worker, so like that execution doesn't like take up the existing rendering process. Yes. Which is, I think that's the worst part of using web apps that have tons of code, right? Is because all of a sudden it has to like garbage collect, and it's just
it's all about keeping the main thread. It's all about keeping the main thread not busy, right? Yeah. So you want to offload as much of the main thread as possible.
Yeah, and you guys do that with the service worker, which works in all browsers, and it's very cool.
So service worker is part of it. The other part of it is just use algorithms that do not force execution of huge amounts of code eagerly all the time, right? Which is what hydration forces, or what dirty checking or VDOM forces you to do, is to just re-execute the code over and over and over again.
Yeah, so I find the whole concept really cool. Clearly you care about performance from a framework level, and you have all this really awesome tooling, but what about like the adoption? Like, how has adoption been, or have you had any challenges there as far as like?
Well, it's a new thing. As all new things, I think it's challenging. I think the other kind of a challenge is that people oftentimes look at the framework and they see syntactically it looks very similar to what they've already familiar with, and so they say like, well, it's just different but the same, right? What they don't realize, or what's kind of hard to get across, is all the magic happens underneath, right? And the consequences of it, right? The places where Qwik shines or starts really shining is when you have a humongous application that is large, right? And that's the point where it's like very difficult for you to switch frameworks, right? Like once you have a humongous application, you're kind of stuck. And so there are tools that other frameworks provide for like breaking your application up into pieces. It's tricky. It's not that simple, right? The value of Qwik is that like you just don't have to think about it. You can just focus on building, and the framework automatically like lazy loads everything, chunks everything to pieces, does statistical analysis of which chunks are needed when, prefetches them in the right order at the right time, so that even if you go to the tunnel, you just don't have to worry about it.
Yeah, it is an interesting point, like how popular React is. Like everything sort of looks the exact same, but like solid works very differently. So does Qwik. Qwik works extremely differently under the hood.
Yes.
But yeah, it all kind of like looks the same because there's the component model and whatever. But
I think right now the companies that are adopting Qwik, they're all focused on performance. Like, so usually it's a lot of e-commerce companies that say like, hey, we have our existing websites and they're just not performing very well. And if you go to Core Web Vitals and Google, Lighthouse scores, you'll see that most websites are just not there.
Right.
And so when you have people who care, and specifically when you have people who have tried to succeed with other technologies and they realize just how much work it is. And fundamentally, the web shows us that most people fail, right? The empirical evidence says, no, most people do not get good scores. Those are the people.
Especially as projects get larger.
Yeah, those are the people right now who are adopting Qwik, and they're just, there's tons of quotes of them saying, like, I can't believe, like, how amazing the performance is, but, like, essentially, I've done nothing, right?
Yeah.
And it's because, fundamentally, Qwik uses a different algorithm, right? Like, instead of re-rendering everything all the time, which notice everything means everything has to be downloaded and present and executed, Qwik is very good at, like, saying, well, no, we don't need to re-render. We don't need to go there. And not only we don't need to go there, but we don't even need to download it, right? And so don't download to the browser, so less code to download. The stuff that you do need to download on a separate thread in a web worker, make it available, and then don't redo all the work that's not necessary. Be really good about moving information from the server to the client so that the client can just continue where the server left off without having to re-execute everything.
Yeah, I always see these demo apps from all these frameworks of like 100, 100, 100, 100, and it's like cached and CDN,
yes,
whatever, like all this, it's like, okay, it's a demo app, right? But when
anybody can get a good score on a demo hello world, right? It's when when the app becomes super complicated with lots of megabytes of like reasons why you have to include this library and that library and the other thing, right?
Yeah.
Whether it's like there's regulations or whatever to force you to include some extra stuff. It's then when you realize like getting 100 out of 100 is next to impossible. And this is why I think we need to just look at the problem in a different way. And this is what Qwik does, right? It says, no, it's not more of the same. It's a different way of looking at the problem.
And there's also a solution that I think you guys, I don't know if you're part of the team or not, but the Party Town. I saw that it's really cool because third-party scripts.
Yeah, for third-party scripts. We move them over to web worker and try to offload again more stuff. It's tricky because Party Town is essentially emulating a main thread on the web worker, and emulations are never perfect, and so nothing just works seamlessly. But when it does work, it's amazing because you get to take a lot of third-party code and just never ship it to the main thread, and that helps a lot.
Yeah, I feel like I have to ask this question because you've seen the web over a pretty long timeline. Like, what do you feel like the big transition points are from like going all the way back to Backbone to like where we are today? Like, what are the big, kind of shifts?
Yeah, I think at the very beginning, everything was essentially an MPA, a multi-page application, right? The server-side rendered everything. And then the big transition was jQuery, right? And the fact that we added interactivity. The trouble with jQuery and using some other technology on the back end like Java or C++ or Python or PHP or whatever is that they're fundamentally two different languages, right? And so there are times where you need to render your address book on a server, and then on the client you say add a new contact. Well, now you're rendering it on the client, and so now you really have to implement the rendering of a contact twice, once for the server, once for the client. And this is what fundamentally makes it difficult to build applications that are both client and the server with two different languages. And so the transition after that was basically we said, you know what, forget all this stuff. Let's just do everything on a client. And SPA became the king, right? And from a developer experience, it's amazing. Like one language, one mental model, it's great. You can just do everything you want. The problem is, well, the SEO doesn't work, right? The startup performance is not very good. And so people try to work around those problems. And we've been trying to work around this problem forever.
Yeah. I mean, we pretty much had to rebuild the browser within the browser, right? Like the single page router and the state management and everything.
We did everything. That in itself is not necessarily the hard part, right? The hard part is that once we realized that SEO doesn't work and the startup performance is not very good, we tried to build these workarounds of server-side pre-rendering. And I say it's a workaround because SPAs were really not meant for this. Like SPA was meant to be like, oh, you have like a Gmail, that long-lived app on the client. Let's do that, right? But people love the developer experience so much that all the meta frameworks that kind of sprouted around it and did server-side pre-rendering, basically solving the problem of SEO and initial rendering time, kind of sprouted around it. And the issue is that they're really a workaround, right? The hydration is the problem. Hydration is basically saying run everything once on a server and then run everything again on the client. And then hopefully when everything runs on the client, it looks just like what the server gave you, right? That's fundamentally what hydration is. And this is why I think the work with Qwik, or what we call resumability, is so important, right? Because what resumability allows you to do is to say, like, well, let's run everything on a server and then continue where the server left off on a client. And this continue where the server left off is important because it means you don't have to redo tons and tons of work, and your startup performance is so much better.
Yeah, it's definitely like really interesting seeing all of these frameworks kind of like tackle it, right? Like Vue as Nuxt and, well, Qwik, you call it Qwik City, right? And then, obviously Next.js and whatever. It's made it fundamentally a little bit difficult for me as an educator or, front-end masters, because now we have to not just teach the client-side framework, but then the full stack, and then the whole thing is kind of...
I think Qwik is unique because it tries to unify the mental model. Well, one of the things we talk about is like this idea of a unified execution model, right? That when you build things in most frameworks, you really have to be aware, like, am I running on a server or am I running on a client? Like on a client, useFX run, but on the server, useFX don't run, right? And so there's different things that you have to be aware of. One thing that I think Qwik does differently is that it like unifies that too and says like, well, there is one mental model of how the thing works. Sometimes it's on a server, sometimes it's on a client, but like that's an implementation detail you don't necessarily have to worry about. And that's what makes the startup performance so nice, is that it's not only that you have a good developer, good performance for the end user, but the developers actually like it because it's now doesn't feel like two separate things. It doesn't feel like a server thing and a client thing. It's just one continuous application.
Yeah, I guess I haven't dug into that as much, so I'll definitely have to.
It makes it really hard. It's really easy to call functions on a. For example, if you have a function in Qwik, you can just wrap it in server $, and now that function will always be pinned to the server, and so it always executes on a server, right? Yeah. So a simple wrapper all of a sudden moves where the code executes, and I think that's powerful.
For sure. I just have to throw it out there because what are your thoughts on htmx solving this problem?
Oh, I think htmx and Astro are all. It's great in the sense that they're all are showing that this is a problem, and let's think about different solutions.
So htmx is like rendering everything kind of on the server, but then you can.
So I think htmx fundamentally has a very different mental model, right? Yeah. With htmx, you don't think of it as I'm building an app with components, etc. Now you have this like, okay, so this is on a server, this is on a client. You kind of have to manage it. I think there are certain kinds of apps like Gmail. I think it just provides an easier mental model to build in a classical sense with components, and so I think things like Qwik would have a better experience for people. Also, there's so many more people trained on how to do the component model, right?
For sure, these days.
So I think htmx is a very unique and cool, fresh air, and the fact that like screams at you and says like, hey, performance is a problem, you should really pay attention, let's do something different. I think that's great. I think if you come from it from the angle of like, I like the mental model of the component hierarchies, and a lot of people do, that's why it's so popular, htmx will not get you there. I think you want something like Qwik.
Cool. How about your horizons, I guess? Like, do you have anything on the horizon, like, even personally, like career-wise or personally? Like,
I think career-wise is I really would like to make Builder a success. I think
we haven't talked about Builder much.
Yeah, so we haven't.
Give at least a elevator pitch.
Yes, the elevator pitch is that Builder is a headless visual CMS.
And you're the CTO, right?
I'm the CTO. Headless visual CMS basically means that there's lots and lots of CMSs out there, right? Content management software. What makes Builder unique is that it's kind of like Wix, but you install it inside of your existing application, right? Wix is like, you go to Wix and you put everything on Wix, and then it's owned by Wix, served by Wix servers. What makes Builder unique is that, like, no, you have your existing React application, and then at some point you realize, oh, gee, I really want the homepage to be editable by our marketing team. Wouldn't it be nice if I could just npm install some component that makes the particular page editable, right? And that's what Builder is. Like, it's this component that you can install, and all of a sudden, certain sections of your page become fully drag and draggable. And the marketing team can go to town and change things, etc. They can schedule, do A/B testing, and they can change their font or height or color or the shade without bugging you. I mean, we all know as engineers, we don't really care to do constant A/B testing or changing fonts or colors or changing the sale amount for a particular day of the month, right?
So it's kind of like giving you a WYSIWYG, like a WordPress style editor on
That's
top
right.
of, like, let's say you actually have a web app.
Yeah, so let's say
Right, and you can embed
That's
that
right.
and like have
let's
that
say you have
visual.
a web app that like sells gadgets or something, like clothing or something of that sort, right? Your web app needs to have a shopping cart. It needs to have connection to the existing inventory, and maybe you have to be customizable because of the shoes or sizes or colors or whatever, right? There's lots of custom code that you can't get on
Right, exactly.
on WordPress
Yeah.
or Wix or anything like that. So you have to build a custom app.
Mm-hmm.
And so the idea is that you build a custom app, but then you want to be able to drag and drop editor. And most CMS systems, when you have a custom app, are not drag and drop. They're basically glorified spreadsheets where you have columns with keys and values, and then you data bind those key and values, right? So it's if you as an engineer did not allow the marketing person to change the font color, then they can't. And if they want to, they have to file an issue with you to say, like, could you please set up a data binding so that I can go into my CMS system and change the color, and I don't have to bug you every single time. And so the engineer does that, creates a PR, sends it across, everything works, and now the marketing comes back and says, can I make the second word blue and the first word red, or second word bold, or something like that, right? And again, you're like, geez, sorry, didn't put that feature in yet. So it becomes like this endless changes to the system. And so the nice thing about a drag and drop editor is that, within this box, you can do whatever you want. But where it gets super cool is that you can give marketing existing components they can drag and drop into their box. So it's not just a box where they can do whatever they want. It's a box into which they can drag existing components that exist.
So you could pretty much create like a design system, but
That's
it's
right.
editable and
That's right.
all that kind of stuff.
That's right.
That's very cool.
That's right.
It's very cool. I have to shout out the Builder.io blog.
Oh, thank you.
Because it's fantastic. Like, whoever is doing that over there, like pushing you guys to actually write technical articles like about web development and whatever. And anybody who's listening to this podcast, like, go check out the Builder.io blog, because it's full of really great stuff. So I just want to.
We try hard. I mean, the point of the blog is to build awareness between developers or between the cool stuff that we're doing. And of course, did you see the latest cool thing, the velocity thing?
I did not.
Oh, it's velocity.builder.io.
Okay.
I'll give you a cool demo. Basically, we really want to, like, as an engineer, the last thing you want to do is to get a Figma page and say, convert the Figma page into HTML, right? That's kind of boring. And so what if you could automate that, where you could just click a button and the whole thing just imports and has the correct Tailwind CSS or whatever CSS system you happen to have, and has proper structure, etc. Because the issue with Figma is that it's an absolute position layout, right? There's no structure to it. It's just like you put stuff on a page. And so the importer that we want to build, or the end goal, is that we want to enable the creative people that go and design something amazing in Figma to be able to just push a button and get it into the builder and push it and publish it, without engineers necessarily not having to be involved, right? Because as an engineer, you want to do cool things, like you want to make the coolest widget, or figure out how to fetch the latest useful information so you can see how many items are still in stock, or what is the predicted delivery date, or something that's much more interesting than figuring out, like, so does bigger font or Helvetica sell more items than Times New Roman, right? Like, that's not something that really is what most engineers are into.
Very cool. How about personal? Anything?
Personal, I think I'm just ready to retire.
Make it success. Make Builder a success.
Builder a success.
Drop that on the world. Drop the mic.
Yes. I've been in this industry for a pretty long time. I think I've had more than my fair share of impact on it. I think I would love to retire and just spend time with the family.
That's fair. I would say that creating AngularJS is a pretty big impact on the industry. So, that sounds great.
Well, I'm hoping that Qwik will be equally big.
Yeah, well, it's definitely gaining steam. So hope so as well. How about then if you're going to retire, then do you have any crazy bucket list items like on the horizon?
I think more woodworking and just traveling and spending time with the family. It's been kind of a rat race for a long time, so it's nice. I do robotics now with kids. The first tech challenge, which school runs, and I'm the coach over there, and it's so much fun to see them solve problems and build things, and going from like I don't know what to do to like okay, break the problem down, build something. Oh, it doesn't work. That's fine. Figure out what doesn't work about it. Fix it. Iterate. Build something else. And just keep doing it over and over until you build something that you're proud of.
That's cool. So how elaborate do these robots get?
Not very elaborate. I mean, they're 6th, 7th, and 8th graders.
Okay, 6th, 7th.
They get pretty elaborate once you get to like high school.
Sure.
In 6th, 7th, 8th, I consider it a success if the robot actually does the task it's supposed to do. And forget.
So what's like a task?
So every year they have a different task, but typically it involves picking something up and then delivering that item somewhere else. So this year they have these hexagonal, they call them pixels. You have to collect them, they're different colors, and then you have to stack them up on a board. If you do it in a specific order, you get more points. And so there is obstructions. So your robot has to be a certain size so that you can navigate around them. Hopefully the robot can move fast. There's an autonomous part where the robot's supposed to do everything by itself. There is the operated part where the driver does actually commands, etc. So it's if the robot can just do the task of like being remotely driven, pick up the item and deliver it somewhere, I consider that a success.
Very cool. So what's the building pieces or what's the technology under the hood to make that happen?
What I like about FTC is that it's pretty open. You can do whatever you want. They have like a predetermined kind of a kit. But you can go crazy with 3D printing and make up your own stuff or laser cutting or whatever. They're pretty loose about what you can and cannot do, which I think is great. It really opens up what kind of solutions you can build.
Yeah, I think the thing that my kids use is those Lego Mindstorms.
Mm-hmm.
So that's
So there is Wex, which is more like Lego, which is very strict about like this is the pieces you're allowed to use, and your robot has to use those pieces and nothing else. That's more for like used by younger kids because it's more constrained.
Cool. So your kid is on the team then, and you're the coach.
Yeah, I'm the coach.
Very cool. How about themes? Is there any kind of driving force behind your career that you're like, this is kind of like what kept me going through and keeps me going? Obviously, you're not retired yet, but
teams are an important part, right? Like, there's only so much you can do by yourself, and I think the hardest thing is, people think that if you have a great idea, people will steal it from you and copy it and run away with it. It turns out the opposite is the case. Like, if you have a great idea, it actually takes a lot of time and effort convincing people that this is actually a good idea. You should try it. It's different from what you've tried before, and it takes a lot of evangelism. So, it's very much a team sport, and convincing people that there are different ways of doing it, or there should be tried different things, is a challenge, and it's a fun one. I enjoy it.
Awesome. Well, with that, I think it's a good place to wrap up. So
awesome.
Thanks for coming on the podcast.
Thanks for having me, Mike.
Yeah, for sure. Hey there, before you go, don't forget we're new at this. So any feedback, whether it's a like or subscribe, we'll take those, or a comment about what you didn't like or what you'd like to see more of in the future. We'll definitely incorporate that into the next episodes. I'm really enjoying these conversations. So any type of feedback would be fantastic, and especially sharing it with your friends and colleagues. So really appreciate it. Thanks for listening. See you in the next one.